Assalamualaikum. Today we will start chapter 4 from Discovering Computer, and the name of the chapter is the component of a system unit. So in this chapter we will discuss the different components of a system. We discuss the different Intel generation, and we discuss the different types of the hardware used inside the system unit. So that is just one of our overview of this chapter. So in this chapter we will discuss the various styles of the system unit. We have a desktop environment, we have a laptop environment, we have a mobile phone. So all are categorized in terms of a style of a systems, and then we move towards the different components used inside the system. We discuss the different motherboard styles. We have different adapter cards available inside the system unit. So we will discuss these things one by one. And then we discuss the most important things in this chapter, that is a machine cycle. We have discussed with the help of 3 to 4 components. We have a control unit involving in it, we have a ALU involving in it. So we will discuss this idea also, and then we differentiate difference between the bits and the bytes, and how bits combines together to make our data. So that is all the thing we will discuss in this chapter. So let's start the chapter. So first of all we have to discuss the system unit. So what is a system unit? That is a case, any type of a case. It may be a metallic body, it's maybe a plastic body, so anything, any case, and inside the case we have electronics components available, so they are categorized as a system unit. So anything with the case, maybe your mobile phone, it's maybe your laptop environment, it's maybe your gaming system. So anything with the case, and inside the case we have electronics components. So this thing is categorized as a system unit. So there is one of a misunderstanding. The processor and the system unit, or the CPU and a system unit, they are not the same thing. The system unit is one case, and inside the case we have one of a CPU or a processor available. So that is the thing related with the system unit, is not the processor. So these are the some of the components we have to discuss inside the system unit. So if you open a desktop environment, so we have these components available. The first one is a drive bay. We have discussed these things one by one. And then we have a power supply. It's used to convert the DC supported by your system. So we have a AC coming in your homes, and then we have one of a power supply which converts into a DC level. So we have a power supply available. We have a sound cards and video cards used to enhance the performance of the overall system, and then you have a processor, and that is a CPU. So look at this thing. The CPU is a integrated part of a system unit, and then you have discussed the different types of memories, and in processor we also discussed the Intel core generations. So these are the some components, 6 components we have to discuss in this chapter. So first of all we have to discuss the base. Base is a opening inside drive. This is some base available in front of you. So this is an opening inside, and you can insert some of our CDs and DVDs into it. So they are categorized as a base. And then the motherboard is a second component, and the motherboard is a printed circuit board. It's also called a printed circuit board. And why it's called a printed circuit board? Because we can see the different patterns over it. So that is the reason. We have a main board, and over that board we have a different slots available for the memories. We have a slot for the processor, and we also have a slot for the sounds and video cards, or the peripheral devices. You can attach the peripheral devices with these slots. But we have a main circuit board, Over that circuit board we work with the different types of the memory, different types of a processor, and different types of sounds and video cards. And sometimes it's also called integrated circuit, because we have billions and trillions of circuits, and the devices are connected over that circuit board, so that is also called a printed circuit board. And these are the sum of cores available in the market. So if we discuss the processor, so it's also called a central processing unit, and its function is carried out the basic instruction to operate the computer. So it's consisting of two components. The first one is a control unit, and the second one is the arithmetical and a logical unit. So we will discuss these two components in the coming slide. But nowadays we have a multi-core processor available in the market. So what is a core? That is a one concept here. If I consider a single processor, so they are categorized as one core. But if I combine the two processors together, so that becomes a dual core processor. Which means we have a two processor integrated in the same chip. So they are categorized as a dual core processor. And then similarly we have a quad core processor. It means we have a 4 processor with the same capacity are integrated in the same chip, in a single chip. So they are categorized as a quad core processor. And similarly we have a multi-core processor available. Maybe you have a octa-core processor available in the market, and that is available, and it works with the server's environment. So with the processor, if you're combining the processors together, so that becomes a dual core, quad cores, octa cores, and so on. So discuss the CPU. It's also called a control unit, and it's a component of a processor that direct and coordinate most of the operation in a computer. It means that is categorized as a brain of a computer. So it's acting like a boss in a company. So everything is controlled by the control unit, and these are the sum of a component to facilitate the control unit. And there's the ALU, arithmetical and logical unit, and it's perform the arithmetic and comparison operations and less than equal to addition, subtraction type of operation by the ALU. So it's perform the arithmetical operation, arithmetical and logical. Arithmetics means addition, subtractions, and logic means less than, equal to, greater than. So these two things are performed by the ALU, and the controlling unit is controlling all the operation. It's also controlling the operation of a computer, and it's also controlling the operation of a ALU. So these two together produce a processor. So inside every processor we have one CPU and one ALU. And if you are working with the dual core processor, so it means we have a 2 CPU and 2 ALU available in a dual core processor. So that is one of our operation. It's also called the processor operation. So what is happening here in this picture? We have one processor with the component of a CPU and ALU, two components, and that becomes a one processor. We have an input device here on your left, and output device on your right, and in between we have a memory. It's your temporary storage memory, it's RAM. And then you have a storage device, it's your permanent memory. So we have discussed the two memories here. That is a temporary memory. It only works when your computer is on, and when you turn off the system, nothing is available in this memory. And we have a second type of a storage, that is a permanent storage. It's maybe your hard drive, it's maybe your USB. So that is a permanent storage. So in this diagram we discuss the two styles of a memory. We discuss these things deeply in a coming slide. So what happens here? So for example, you want to perform the arithmetical operation from your computer, and the arithmetic operation is that where you have to add up two digits, so 2 plus 3. So that is the arithmetical operation you have to perform. So what's happened, you enter from your input device, maybe your keyboard, so 2 is going from the input device into a memory, so it's not come directly towards the processor. So whatever you enter from your input device is first comes into a memory unit in terms of a data. So what's happened after that, the CU control unit fetch the information, fetch the data from the memory and check is it a arithmetical operation. So 2 plus 3, yes, it is a arithmetical operation, so it's handed over this operation towards the ALU, and now ALU is a arithmetical logical unit, is calculate the result and send back the results towards the CU, and then CU send the results back towards the memory, and now memory is connecting with the outputs. It's up to us, it's may display at the output device, it's may store into your permanent storage. So that is a flow of information, and that's procedure, that overall circle is called the processor operation. So I repeated it again. So what's happened, 2 plus 3 is the arithmetical operation, and that is the thing we have to calculate from your computer. So you enter the information from the input devices, goes into a memory. The CU is fetch the information from the memory. Memory is not capable of sending the information towards the CU. CU is fetch the information from the memory, send towards the ALU, ALU calculate the result, send back the result towards the CU, and then CU sends back the result towards the memory, and it may goes towards the output device, may goes towards the storage device. So that is a one operation. And the second operation we see as a copy paste operation, and copy from a C drive pasting into some other drive. So that is a copy paste operation, and in this operation we see the ALU is not working in this type of operation. So what's happened, you send the information from your mouse from the input devices, again goes towards the memory. CU fetch the information from the memory. Now CU is controlling authority. CU is check is it arithmetical operation. No, it's not arithmetical operation. So what's happened, the CU is send the instruction towards the memory, and memory send the data towards a storage unit. It may be a C drive here, so it's copy, the CU copy the data from a C drive and then paste towards a D drive. So in this operation the ALU is not responsible for this type of operation. So we have a two operation. One is a copy paste operation in which the ALU is not working, and then second is a arithmetic and logical unit, the previous one. So repeated it again, copy paste operation. The data is coming from an input device towards the memory. CU fetch the data from a memory. It's not arithmetical operation, so it's send the commands towards the storage area, C storage area, copy the data, and the copy data moves towards the memory, and now from the memory it moves towards the D drive or any type of other storage area. It may be copying from your computer and then pasting into a USB. So that is the same idea. The ALU is not responsible in this type of operation. And that process we discussed earlier, it's also called a machine cycle. It's a FDES cycle. So in this diagram we see a machine cycle here. F stands for fetch, D for decode, E for execute, and S for store. So what's happened in this diagram here, so look at this thing, that's purple strip is your memory unit, it's your RAM, it's your volatile storage, and then we'll have a processor available, the ALU and CU is available here. So what's happened, you enter the information from your input device, and that information moves into your memory, and from the memory the CU is fetch the data, fetch the information from the memory. CU decode the information. Look at this thing. We have to perform this operation 100 across 48, and that is a decimal number, but we also discussed the computer is working on a binary level. So what's happened? The CU is decode the information. Decoding is here. So CU is decoding the decimal number into a binary numbers, and then send the information towards the ALU for execution. So here is the execution, and then it's after the execution, the CU sends back the data towards the storage area, which is your RAM. So it stored the data again into the RAM. So it's a one cycle available here. Fetch by the CU, decode by the CU, sets the data towards the ALU for execution, and then after the execution we have to store the data back into the memory unit. So that is also called a machine cycle. So that is again one attribute of a processor. Most of the processor nowadays working with the pipelining technique. So what is the pipelining? Here we have discussed the idea of a machine cycle with pipelining and a machine cycle without pipelining. So first of all, we discussed the machine cycle previously. So what's happened here? Fetch, decode, execute, store. That is the one machine cycle available. It's mean if you enter anything, so the instruction is follow this type of a pattern, and that pattern is a machine cycle. So what's happening without pipelining? The first instruction comes, and the second is working here. So after the completion of a second instruction, the first is going to be executed. So it's a pipelining approach. It means we have just a single road for the traffic. When the first moves forward, and then the seconds comes. So that is first in first out condition. So that is called a without pipelining approach, and most of the processors is not working nowadays with this type of a technology. And nowadays the processors are working with a pipelining approach. And look at this thing, we have a same machine cycle: fetch, decode, execute, and store. But what happens here, for example, the instruction 3 is reached towards the decoding phase, the computer fetch the instruction 4, and similarly if I discuss the instruction 2, it's reached towards the execution phase, your CU is fetch the third instruction. Okay, similarly the CU fetch the fourth instruction. So that is a simultaneous operation. That is a we also call a parallel processing. So everything is happening in a parallel way. That is a serial communication. The first instruction, the second instruction is going to be executed by the machine cycle, and then the first comes. Okay, but what happens here, we have a different instruction working at a different level. The instruction 4 is working up to the fetch level, the instruction 3 is towards the decoding level, the instruction 2 is towards the execution level, and similarly instruction 1 moves towards a store level. So we have a different levels available when working with that with pipelining approach, and with the help of a with pipelining approach we can perform multiple tasks at the same time. So again discussing the processor. So processor is also consisting of a number of registers. So registers are smallest units to store the data and instructions. So it's a temporary hold data and instruction, and that is the smallest units. And if we combine the registers together, so that becomes your memories. So again, our processor is again consisting of a small registers. When CU is fetch the data from the memory or storage area, so it's placed the data in some location inside the processor. So we have small registers available. So when the CU fetch the data, so it's hold the data inside these registers. And the second parameter is a system clock that control the overall operation of our system, that is working in gigahertz. And if you go into the properties of your system, so we have a system clock available. So that is again a very important criteria when deciding the processor speed. Higher the clock speed, better is the performance. So if you go into the properties of your system, wait a minute. So if you go into the properties of your system, so look at this thing. You have a Intel Core i5. We discussed this thing in coming slides, but you see a 1.8 gigahertz, 2.3 gigahertz. So that is a speed of my system. That is a maximum speed of my system, and that is a nominal speed of my system. So 1.8 gigahertz, it means my computer is capable of performing 1.8 giga operation in 1 second. So what is a giga? It's a 10 raised power 12. It's a 1.8 into 10 raised power 12 operation in a single second. So my system is capable of producing these type of results, and not the system, but my processor is capable. So you also go into your system properties and see what is the clock speed of your system. So coming back towards the processor, so we have a leading manufacturers available in the processor industry. So we have Intel is a leading manufacturer. The second leading manufacturer is AMD. So look at this thing. We have a server environment, we have a desktop environment here, we have a notebook environment available here. So what's happened if you see the server environment? So the Intel is here, and Xeon is the name of the processor. And look at the working cores. We have a 8 core, 6 core, quad core, and dual core. Xeon is available for the server environment. That is a very famous processor when working with the servers. So AMD is also here. So maximum it goes towards the 8 core processor. But if you move towards a desktop environment, so you see the Core i7 is the latest one by the Intel, but the core level is 6. It's a 6 core quad core. It's maybe a 6 core, it's maybe a quad core processor. Core i7 doesn't mean that it's consisting of a 7 cores. It's never ever means this thing. So look at this thing. The Core i7 is may consisting of a 6 core. It's may consisting of a 4 cores. Similarly, we have a Core i5, Core i3 is here, and AMD is also coming with a 6 core, quad core, triple core processor available. And similarly, if you go towards a notebook environment, so we have a quad core is here, we have a quad core with the Core i7, we have a quad core with the Core i7 Extreme. So these are the Intel. But you see, in your desktop environment and in your notebook environment, you have Intel processors are available. So where is the AMD? So AMD is also one of a leading manufacturer, but AMD is working with your mobile phone. We don't never see the Intel chips in your mobile phone. The AMD is a leading manufacturer in a mobile phone processor. But if you go towards a desktop and notebook environment, Intel is working with these these 3 styles of a system mainly. AMD is mostly working with the mobile phone and tablet like PCs. So yes, when processor is performing 1.8 gigahertz of operation in a single second, so of course the chip is going to be heat up. So we have a different mechanism to cool down the processor. The first mechanism is called a heat sink. So in this picture we see a heat sink available. A gray color area or a chip is here, and over that chip we have a one fan available, and below that chip we have a processor, and over the processor we have a one of a heat sink available. It's catch the all the heat generated by the processor, and the fan is working in a fan out condition. It means it's absorb the heat from the processor and leave it towards the environment. So that is one of a mechanism to cool down the system. The second technique is called a liquid cooling technology, and you see a copper wiring, hollow copper wiring is available in your motherboard. So inside this copper we have a liquid flow flowing through this copper pipe. So this is another mechanism to cool down the system. Most of the computer nowadays are working with this technology, but it's also working with the desktop environment mainly. The technique is working with the desktop environment mainly, and this technology is working with the notebook style of systems.